Close your eyes for a moment. Picture the Earth beneath you. Now, zoom out, past the Moon, the Sun, a swirling pinwheel of stars we call the Milky Way. Now, hold that image and ask yourself this single question. If all of this is moving, then where is it all going? What is the ultimate destination of every star, every planet, every single atom in the cosmos? The answer is not a place on a map. It is a story written in the fabric of reality itself, and it is more strange and terrifying and beautiful than you can possibly imagine. Welcome. You're listening to a journey to the end of all things. We're not just talking about the future of Earth, or the Sun, or even our galaxy. We are talking about the ultimate fate of the entire universe. It is a forecast based on the iron laws of physics, on observations that stretch to the very edge of the visible cosmos. So, let's begin at the only place we can, with the single most important discovery in modern cosmology. In the 1920s, an astronomer named Edwin Hubble made a shocking observation. By measuring the light from distant galaxies, he found that they were all, almost without exception, racing away from us. The universe was expanding. This was monumental. But the real twist came nearly 70 years later, in the late 1990s, when two teams of scientists set out to measure how this expansion was changing over time. They expected to find that the gravity of all the matter in the cosmos was acting as a brake, gradually slowing the expansion down. They found the exact opposite. The expansion of the universe wasn't slowing, it was accelerating. Something was actively pushing galaxies apart, and that something was stronger than gravity itself. This something was given a name that is both humble and profound: dark energy. This is the central driving force behind where everything is going. Dark energy isn't a guess. It accounts for about 68% of all the energy in the universe. It is the dominant player in the cosmic game, and its influence is only getting stronger. As space stretches, more space appears, which means more dark energy, which causes more stretching. A feedback loop written into the geometry of reality. So, if dark energy is in the driver's seat, and it has its foot pressing down harder on the accelerator with every passing moment, what does the road ahead look like? Let's take the journey, step by step, from the near future to the very end of time. Our first stop is the death of our local neighborhood. The acceleration isn't just pushing distant galaxies away, it will eventually tear apart everything that is not bound together by gravity. First to go will be the grand view. In about 2 to 3 billion years, the Andromeda Galaxy will actually merge with our Milky Way. A glorious, slow-motion dance of billions of stars. But after that merger, the acceleration will take over. Over tens of billions of years, every other galaxy in our observable universe will be pulled away by the stretching space. Their light will redden, fade, and wink out. They will not just be far away. They will be beyond any conceivable horizon, moving away from us faster than the speed of light. We are in the realm of trillions of years. Stars will continue to form for a time, but eventually, the raw material, the interstellar gas and dust, will be used up. The last stars will flicker out. The universe will be populated by the corpses of stars, white dwarfs, neutron stars, and black holes. For eons, these dead relics will orbit in the darkness. But nothing lasts forever. Through a quantum mechanical process called proton decay, still theoretical but predicted by many grand unified theories, the very matter that makes up these stellar corpses may itself be unstable. Planets will dissolve. Dead stars will fade. All complex matter will cease to exist. What remains? A diffuse, ever colder soup of subatomic particles, photons, and black holes. For an almost infinite span of time, black holes will be the last giants of the cosmos. They will loom in the darkness, the only structures of any significance. But they, too, are not eternal. Stephen Hawking taught us that black holes slowly radiate away their mass, a faint whisper known as Hawking radiation. But eventually, even the last black hole will give one final, faint pop of radiation and vanish. We have now reached a stage often called the dark era. The universe is a near-perfect vacuum. The temperature approaches absolute zero. Space is incomprehensibly vast and empty. A photon from the final black hole's evaporation might travel for aeons without ever hitting a single particle. There is no structure, no change, no complexity, just an eternal, expanding, cold, silent nothingness. Is this the end of the story? For a long time, cosmologists thought so. This bleak, cold fate was known as the heat death or big freeze. But in recent years, thinking has shifted towards an even more profound, and in some ways more terrifying, possibility. Remember our engine, dark energy. We've assumed it's a constant force, a property of space itself. But what if it isn't? What if it can change? This is where the ultimate destination gets truly strange. One leading theory suggests dark energy is a field that could decay or transform. This opens up several catastrophic possibilities, collectively known as the Big Rip. Imagine if the acceleration doesn't just outpace gravity, but grows infinitely stronger. If the repulsive force of dark energy increases without limit, then no force in the universe can resist it. Not gravity, not electromagnetism, not even the nuclear forces that hold atoms together. Billions of years before even the stars die out, the acceleration would become so fierce that it would start tearing apart bound structures. First, galaxy clusters would be shredded, then individual galaxies. Then, within our own galaxy, solar systems would be ripped from their orbits. As the end approached, stars and planets would be torn apart. In the final moments, atoms would be ripped asunder, nuclei stripped from electrons. Finally, in a final, unimaginable flash, spacetime itself would be shredded at the quantum level. The universe would end not with a whimper, but with a fundamental rupture in the fabric of reality. A true, finite end of everything, including time. Alternatively, dark energy could decay, causing a big crunch, a reversal of the expansion, pulling the universe back into a hot, dense singularity, perhaps birthing a new universe in a cyclical cosmos. Or, quantum fluctuations in the vast, cold void of the dark era could, given literally infinite time, spontaneously generate a new Big Bang in a process called quantum tunneling, a Boltzmann brain, or even a new universe. So, is this a nihilistic story? Is the ultimate destination a void that renders all of our struggles, our art, our science, our love meaningless? I would argue the exact opposite. The meaning of a story is not contained solely in its final page. The beauty of a symphony is not negated by its final note fading into silence. The universe is a story, and we are a part of that story, a fleeting, brilliant, conscious chapter. For a brief, glorious moment in cosmic time, the universe has organized itself into beings that can look up, question its origins, trace its history, and forecast its fate. We are the universe's way of understanding itself. Where is everything in the universe going? It is going toward silence, toward equilibrium, toward a state of no change. Next time you feel small or insignificant, remember this. You are a collection of atoms that once resided inside a star, now assembled into a form that can contemplate the beginning and the end of all things. You are a conscious flicker in a vast, darkening cosmos, and in that flicker, in this fleeting moment of light and thought, lies a profound and beautiful defiance. We are here, we are looking, and in asking, where are we going? We have found, against all odds, exactly where we are.